Hello 8th grade, my name is Mr. Rogers and you're watching the video lecture for section 1-1 on magnetism in your book. And there's actually going to be two videos for this section, and there's to start off with, what are we going to be talking about here? Well, there's a couple things in this video. This is really the beginning of the unit. So what I want you guys to do is, if I say to write something down, write it down. Remember the Cornell method of notes. That's what we're going to use. And so to start off here, first of all, I'm wearing my red, red rockets there, 8th grade. Holla. So today, guys, we want to start with trying to define what magnetism is. Where does it come from? That's kind of our big idea, and it's starting with the atom. And I know we probably have some background on the atom. The atom is the smallest particle of matter that can still be considered matter. So I can theoretically have one atom of gold. Gold is an element. I could have one atom of lead. That'd be an element also. So I can have one atom of that and still have the properties of lead. So an atom, and here we're thinking about atoms of things that are magnetic. So these would be iron, elements like iron, nickel, cobalt, which are metals and elements, and they tend to be magnetic. And so what's happening here is, let's look at the basic structure of an atom real quick. So a couple basic parts. We'll talk more in depth about it in the future chapters, but kind of a recap. Remember, there's a nucleus to an atom. That's the center. And in this nucleus are two particles. One is known as a neutron. One is known as the proton. And that's really where all the mass is of the atom, is there with the protons and neutrons. And on the outside of that, and this is not to scale by any means. The nucleus is actually very, 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 very tiny. And these electrons are bouncing out way, way, way farther away. They'd be way off the screen. They'd be out in a cornfield from the school where I'm at right now. So it's kind of a basic model, and so we have our two parts here in the middle. The neutrons are considered to have no charge. They don't have an electrical charge at all. Protons, positive, they have a positive charge. Now, the most important ones for magnetism are on the outside, and that's these electrons. So these electrons have a negative charge, and usually they spin randomly. In most elements they spin, there's no real rhyme or reason. But in magnetic elements, they tend to kind of spin the same direction. So they get kind of a polarity, a positive and negative, we would say, because they're spinning in a certain direction or a certain area. So they're kind of spinning the same way. And so if we have enough atoms spinning the same way, it can make a substance magnetic. And so I want to start here with the basic structure of an atom, because it's kind of important. Knowing electrons spinning in the same direction is what's helping create magnetism. So this all starts with different types of elements. And there's about 100 different materials that make up all matter. And it starts with that tiny, tiny atom. And that's the smallest particle of an element. And again, it has just those three main parts. The nucleus, the center of every atom, contains the protons and neutrons. The proton is a positive charge. Electrons have the negative charge around them. And electrons on the outside. So that's a basic part. And we need to know that to kind of think about how these magnetic domains work. So a magnetic domain. A magnetic domain, we have to think about, again, atoms. In any piece of metal, if you think of a bar magnet I used in class today, if we think about that, there's an infinite number of atoms in there. There's billions and billions and billions and billions. I couldn't even count. There's so many billions of atoms in there of metal. And so a magnetic domain is a region where magnetic fields of all atoms are lined up. We have a magnetic domain, and these are areas, and there's billions of domains in any magnet. So each domain is billions of atoms. There's billions of domains inside of a magnet. And in most materials, again, these domains kind of go random directions. There's no rhyme or reason. So when we have a magnetic material, all or most of those domains, again, billions of domains containing billions of atoms, most of them pointing the same way, kind of more than half, you get something that's magnetized. So to visualize this, in this first picture here, we have, let's just say this is a piece of iron, and we can see these domains. I've just drawn in a few. Remember, there'd be millions or billions of domains in any piece of unmagnetized iron. So they're kind of going up, down, left, right. There's no rhyme or reason. They're not going the same direction. If this was magnetized, if it was a magnet on this bottom piece of iron, so this is a magnetized, say it's a bar magnet, you can see most of those arrows or domains are pointing the same direction. They're pointing this way. And so those domains are lined up, so now this is magnetized. Those domains of billions of domains containing billions of atoms, and those billions of electrons are all spinning the same way, kind of creating that directional flow of the charge. So we get a magnetic field being produced around our magnet. Alright guys, this is the end of video 1. on kind of the basics of an atom and how they relate to magnetism. There'll be a video too you need to watch also, but thank you for watching, and we'll see you guys along the way.